Hi everybody, it's Miss Epstein here with your Maths Parent Workshop for April 2021. I hope a lot of this actually rings a bell from when we did the homeschooling. You will have seen a lot of these methods in school anyway during that time. So hopefully this shouldn't be too long. I'm going to try not to make it too long, which is one of my areas of development. So I will try and be quick. Okay, so the aims for today, I want to share with you the methods that we use in school for each of the mathematical operations, which are addition, subtraction, multiplication, division. I will probably touch on missing number and fraction as well, very quickly, possibly at the end. This is a good opportunity to direct you to some useful websites which will support the children's learning at home and to give you some ideas of how to support maths learning at home yourselves. So if we start with addition, for addition we partition. We use a method that prepares the children for the next step, which would be column method, whereby we split the numbers into tens and ones, add the tens, add the ones and put them back together. There's a fantastic song that you're going to really love that I have attached here to the PowerPoint, but you can find it just by going on to YouTube and typing in partition addition song. The children love singing it, they all know it, and it's quite a nice way to help them to remember the steps. There's an example above, 14 add 13, partition them into tens and then ones, and then add the tens, add the ones. I will do an example of each at the end as well on the whiteboard so you can see exactly how we model it in school. I won't play you the whole song, that's for you to do in your own time, but hopefully that supports the children at home because they're used to using that method in school. Once they can add simple numbers, also with, I should say actually, with single digit numbers, if it's 9 add 5, we would encourage the children to put 9 in their head because it's the biggest number and just count on 5 on their fingers. And then obviously partition for those 2-digit numbers. Once they can do that, they use that knowledge and understanding for reasoning questions. Some examples are here. So for example, there's 2 number sentences or 2 calculations. They have to solve both and work out which is more valuable. So greater, less than or equal to, using those signs. They're used to using those in school. Completing a missing number sentence. So it's 5 add 3, which obviously on that side equals 8, equals 6 add what? What goes with 6 that makes the same as 5 add 3? 10 more, 10 less, that's something that children really need to be practicing a lot at home, actually, adding and subtracting tens. To be able to do the subtraction method, which I'll show you in a moment, they need to be able to add and subtract tens in their heads. Sometimes they have to be using their reasoning to understand which numbers add together and use the trial and error, really, and actually choose 2 numbers that they think might add up to 60, for example, in this case. And keep trying until they actually get to the right answer. Sometimes it's about perseverance, resilience, and actually sort of trial and error and working methodically. Then you've got word problems. For example, Katie had 12 marbles, Jim has 13 more than Katie. How many do they have altogether? So you might have one that says Katie has 12, Jim has 13. Easily add those together. But actually, if Katie's got 12 and Jim has 13 more than Katie, he's actually got 25, and then add them together. So there's quite a few steps involved in that one, for example. A lot of the time we find that with with word problems, the children just add all the numbers. So actually it's really important that they're able to pull out those keywords that tell them altogether, for example, is addition. But if it says what is the difference, then they need to subtract. So it's about sort of getting them to understand what actually the question's asking through practice. Subtraction, we use a number line. We put the smallest number at the start for subtraction. I use that annoying hissing sound to help the children to remember those steps. Smallest number at the start for subtraction, biggest number at the end. I've taught this in the past whereby we imagine we're a bunny rabbit and we start at the hutch and we have to jump to the carrot. we can only do 2 kinds of jumps. We can do bionic jumps of 10 because we're a bionic bunny, or we can do little hops of 1. So I say to the children, right, we're on 26. Can I add a 10? Yes, to get to 36, which is why they need to be able to add 10s in their heads. If I jump another 10, I'm going to jump over my carrot, which I land on 46. So I have to do 1s instead. We then use our deans, or our 10 frames, underneath to help us understand whether how many jumps we've done or what the jumps are worth. So 10, 11, 12, 13, 14, 15, 16 in this case. Again, I will show an example at the end. Again, with reasoning problems with subtraction, first of all, there's the idea that it's how many are left. That's key. You'll see on a couple of these, it uses the word how many are left. That usually means that they're taking away. For example, there are 100 chocolate chips in the bag. Sita uses 25 grams, and Ben uses 35 grams. How many grams of chocolate chips are left in the bag? With a question like this in year 2, it's a 2-step problem. So they actually would get 1 mark just for writing the number sentence. So they write 100, take away 25, take away 35. Even if they don't find the answer or they get the answer wrong, they actually get 1 mark. To then solve it, they would then get the 2nd mark. The one above is about the change of the cost of fruit. Again, it's that 10p. So it's about changing, adding, subtracting 10s. Really, really key part of year 2. And again, it's similar to the one we did before with the trial and error for finding which number matches into that particular number sentence. Multiplication we teach in a range of ways. Sometimes we do it through something called repeated addition. So 4 times 2 is 4 lots of 2 or 2 lots of 4. So if it's 4 lots of 2, we say 4 fingers, 2, 4, 6, 8. If it's 4 lots of 2, we would do 4 add 4, for example. So, or 2 lots of 4, I should say. So we count repeated addition, which links to their times tables, or they can draw an array, which is an interesting way of showing the children exactly what multiplication looks like. And actually they can use this to recognise that if you turn the array round, it's exactly the same number sentence. So if it's 2 times 5, it's the same as 5 times 2. So when they come to solving them later in their heads, which they can do some of them already, if it's 5 times 2 and they're more confident in counting in 2s than they are 5s, they can choose, which is something called commutative law, which we have covered in school. The idea that actually you can do addition and multiplication in any order and you'll still get the right answer. With subtraction and division, you have to do it in a particular order, otherwise it will change your answer. Division is taught through grouping, so to understand that it's actually about sharing into equal groups. So for example, if the number was 15, they would share that into 5 groups for this number sentence, and they would see that there's 3 in each group. It's important they recognise that they are equal groups or even groups, which actually leads into their fractions learning later on too. We use very much the same method for fractions, so if they're really secure on division, then that helps a great deal with fractions. When children become more confident with their times tables, actually we sometimes ask them to do this in their head, because if they were to do 70 divided by 10 using the grouping method, they'd be drawing 70 dots, and it's very likely it's A, going to take them a long time, and B, they're probably going to miscount somewhere along the way. So the easier way for them to do that would be how many 10s are in 70, count up in 10s until they get to 70 on their fingers. So 10, 20, 30, 40, 50, 60, 70, they'll have 7 fingers and they'll know that there's 7 10s in 70. Great way to practice multiplication and division is through TT Rockstars. The children have access to that at home. They can use that as much as or as little as they need to, but the more they practice, the more confident and the quicker they will get at doing that. And actually, although they're only in year 2 now, it's a key part of the Key Stage 2 maths curriculum, and there is the year 4 times table test, which I know seems a long time away, but the more secure they are now on those 2s, 5s and 10s as a minimum will really, really help them later down the line. So if we move on to the multiplication and division reasoning, it's much the same really in the style as the previous ones. So you'll have word problems. For example, Sita puts 10 balls in each bag. How many balls are there in the bags altogether? Recognising that each group means 10, they can count in 10s. True or false, 5 add 5 is the same as 2 add 2 add 2 add 2 add 2. Well, actually, they can solve those problems and do 5 add 5 is 10 or 2 add 2 add 2. But that links to the repeated addition that we talked about before with multiplication. So 5 plus 5 is the same as 2 times 5. 2 add 2 add 2 add 2 add 2 is again the same as 5 times 2 or 2 times 5. Ben has 5 marbles. Kemi has 7 times that number. How many does Kemi have? So 7 times 5. So it's about that different vocabulary. Lots of, groups of, times, multiply. They will come across lots of those different words for the same thing. The one underneath with the 5, the 40 and the 8, the children have to fill in number sentences that use the same numbers. They need to understand actually that 5 times 8 and 8 times 5 give the same answer, but actually that first number in the division number sentence needs to be the biggest, and that applies also for subtraction. The bigger number has to go at the start, which I touched on the commutative law, which basically is times and add can be switched around, but the other two can't. There's also a 2-step problem at the bottom there, which says Ben has 7 bags of grapes. Each bag has 10 grapes. Well, 7 lots of 10 or 7 groups of 10 is 70. He gives 25 grapes to his friend. How many does he have left? Which draws on their subtraction knowledge. They need to be able to do 7 times 10 and then take away the 25. We encourage children to make sure that they show their working. So 7 times 5 if they want, 7 times 10 if they want to do that in their head is fine. But actually then I would expect them to do 70 take away 25 on the number line in the way that we showed before. Missing number, they're learning to use this triangle, which has worked really, really well. But the most important thing to be able to do this is to know where the biggest number should be in any number sentence. So if it's an addition number sentence or multiplication, it will be after the equals. If it's subtraction or division, it will be at the beginning. They put the biggest number at the top of the triangle. The other two can go anywhere and it does the sentence for them. Things to do at home is learn number bonds of 10, 20, 50 and 100. They come up all the time throughout year 2 and with Key Stage 2 actually. So it's really, really key that they're practicing those. Learn times table and division facts at speed if possible for 2, 5s and 10s. TT Rockstars is a great way for them to practice and also for them to see the improvement in their times and their scores. Regular arithmetic and word problems. Like I said earlier, with the word problems often the children just add any numbers that they see, but actually recognising if it's subtraction or if it's division or multiplication as well. And real life maths, actually making maths part of their daily life and making it fun for them, whether it comes to cooking or baking and measuring those ingredients, reading a scale. If you have a modern scale that tells you it with digits, it might be a good idea to invest in an older one, maybe from a car boot sale, that actually still uses the scale, because the children can read using the scales, and that's something they need to do in school as well. If they measuring flour for a cake, for example, and measuring also with a ruler or with a tape measure. Actually, that's really, really helpful, real life maths as well. There's lots of websites on the internet that you can get free resources, but these are some that I would recommend. So TT Rockstars and Numbots, the school pay for and they have access to. Top Marks is also great. There's loads of games on there for all different areas of maths, not just for year 2, but for across the primary curriculum as they get older, or if you have other children lower down the school as well. A website called Transum, which actually has some really, really great activities, again, for the entire primary curriculum. So have a look at the activities that are suitable for your child, but a lot of them are really engaging. There's one called, for example, Quiculations. You can put it on a specific speed and a specific difficulty level. And actually, it's just arithmetic questions that pop up at random that the children can solve. Snappy Maths, there's loads on there. For example, it's a great place to find practice of telling the time, practice of reading scales, arithmetic, of course, word problems. There's all sorts on there. That's great. That's all free. Twinkle is a paid subscription, but there are some free activities that might be useful for you at home. And also White Rose Maths. Again, it is a subscription that is chargeable, but actually there are some free activities. There's parent workbooks on there. There's quite a lot actually that's been left on there from school closures. So that's a good place to look. And one other that I've forgotten to write on here is called Oak Academy. There's things online, there's lessons online, there's also BBC Bite Size where they do specific lessons. So one really good thing to have come out of the closures is the amount of things you can access at home to support learning. Another thing to notice is actually there is an example video of each of these methods that we use in school for fractions and missing number as well, that are all on the Purple Mash Year 2 blog. So if your child logs into Purple Mash, go to the top, there's a world icon. They click on the world icon and they go to shared blogs, I believe it is. They will find the Year 2 blog and the maths methods. They're all there for you to use as much or as little as necessary. Okay, I'm very quickly going to go through some examples of each of the methods. So, for example, we would do 13 out of 14. Split the numbers into 10s and 1s. Add the 10s. Add the 1s. And then they put them together. In this case, it will be 7 and then 20, 27. Which you can see gets them ready for column. later on down the line. If we do subtraction, we could do 53, take away 21, for example. Number line, smallest at the start, biggest at the end. And then I ask myself, can I add a 10? That's my little thought bubble, my terrible drawing. Or can I add a 1? Add 10, this is why the speed of adding 10s is a really good thing to practice at home. 41, another 10, gets me to 51. And then it will just be 1s, otherwise I'll jump over the number that I need to get to. And then I draw my 10s, deans, just to help me to visualise what it is that I've jumped. 10, 20, 30, 31, 32. Multiplication, I would do, if it was, for example, 3 times 4, for example, if I don't know how to do my 3s or my 4 times table, 3 rows with 4 in each. 2, 3, 4. And I've drawn myself an array. I can count the dots, which will get me to 12, or I could do 3 lots of 4, 4, add 4, add 4, or obviously the same with the 3s, 3, add 3, add 3, add 3, because it'd be 4 times this time, which would get me 12. So we've got repeated addition to the right, and on the left the array there. Division, for example, if it were 16 divided by 4, 4 groups, 16 dots. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and there's 4 in each. Okay, so my answer would be 4 in that case, which also applies for fractions. If I was to do fractions in the same way, so if it was a quarter of 16, it'd be exactly the same. If I was to then change that to 3/4 of 16, I'd do 4 groups, share out the dots, 9, 10, 11, 12, 13, 14, 15, 16. It's not neater on paper. And then so that's divided by the bottom times by that top number. We've got 4 in each. 4, 4, 4, 4, and that would equal 12. Very quickly, if we look at missing numbers, though, blank add 6 equals, say, 19. I draw that triangle. That cross sign always goes at the bottom and those line signs go there. It looks like a little face, really. The big number is 19, so that would go at the top. 6 can go either side, and it gives me a number sentence. 19 take away 6. If I was to do that on a number line, it would give me 13. It also works for example, division. So blank divided by 5 equals 2. Do my triangle. I do my cross sign at the bottom again, and my line sign here at the sides. The big number in this case, though, would go here at the start. So I leave the top empty. 5 and 2 can go in any order. My number sentence is 5 times 2, which I know equals 10, and that gives me my answer, which hopefully is a little bit clearer as well, rather than me just sort of explaining it to actually see it. Might be helpful. Don't forget, though, it is always available on Purple Mash 2. Thank you very much for your time. I hope this has been helpful. Any questions, please speak to your child's class teacher, or put a note in the diary, or send us an email through admin, and we'll get back to you with any support that you need. Thanks so much. Take care.